why do we need to resolve vectors? Resolution, from the term resolution, means to resolve. So your main vector is there. You are splitting it into its various components. That is what is meant by resolution of vectors. Let's say if I have a main vector, let's say V. Let's say I have taken out its one component V1 here and one more component V2. At this angle, θ1, at this angle, θ2. So I can say this V vector is made up of its V1 and V2 components. We can combine these components and get our main vector. So resolution means you have the main vector and you have split them into their respective components. Like if I have 5, I can write it 3 and 2. So when I add 2 and 3, I'll get the 5 back, right? But this is not a, this is about vectors. So it is not necessary that every time that I add 3 and 2, I'll get 5. Correct? So this is just an example, random example. Now, you have when these angles between, or let's say, if I write this θ2 and this θ1 as one complete angle theta. Okay, means the angle between both the components V1 and V2. So see, if this angle becomes 90 degree, somehow let's say this angle, this becomes theta becomes 90 degree, we call it as the rectangular components which are of use to you. This random one is of no use to you. Neither in class 11, 12th, NEET, JEE Mains, JEE Advanced, nobody is going to ask you from here. This is not a part of your syllabus. You have to focus on rectangular components. But what is meant by the resolution of vectors? It's the process of splitting of vectors into its components, acting in different directions. So wherever the components are, we are just taking these components and we are segregating it. Like what did we do in the parallelogram law? We had various components of the resultant and we used to combine it to get our resultant. So think it, you are going reverse. From the resultant, you are splitting it. This is like this only. This is the resultant. This one becomes the resultant. Now, coming to the rectangular components and why are they so needed here? Why are these rectangular components so much needed here? Is that everything we need to calculate should be either along x-axis or y-axis. Okay, along x-axis and y-axis. If this is my coordinate system and I'm getting something along x-axis, I'll be able to solve it. If I get something along y-axis, I'll be able to solve it. But if I get a vector like this, let's say a force of 3 Newton is there at an angle of 60 degrees. This is present. So this is in the plane of it. So we need to resolve and take out its x component on this side and take out its y component. That's why we require this. And as soon as the angle between both the components, let's say x component and the y component, this becomes 90 degree. Let's say this is our main vector V. As soon as this angle becomes 90 degree, we use the term rectangular component. Now, how do we resolve the vectors? This is all just the theory part that you should know, resolution's meaning. So rectangular components, when you are taking it, okay, one more thing. When you have these rectangular components, it doesn't mean that you will draw the axes every time. You can get vectors in any direction. Okay, vectors can be, suppose there's a mirror. Let's say this is the normal to the mirror. You have done it in your class 10. That's why I'm giving you your ray optics example. So you had the normal reaction like this. If incident ray, or let's say the ball has hit the mirror with a v velocity. So see, this is such a random direction. How can you manage so many directions, so many points, so many coordinates? You need to have a fixed system. So it's not necessary that you have to look for the axis. Anytime, if I get this was my velocity here, acting like this, I'll take out its x component, I'll take out its y component. That's it. You need to take out x and y components. Now, how do you take these x and y components? Let me tell you. First, write it till here. Then I'll explain. Okay, how do we solve it? Okay. I think both of you have written. Let's see how we actually resolve the components. See, when you have a component, let's say this is the moon vector. Okay. Let's say this is some F1 force is there. F force is there. It has two components along x-axis and y-axis. Why am I focusing on axis? Because rectangular components can be obtained when x and y axes are there because they both are perpendicular to each other. So ultimately, when the angle between both the components is 90 degree, it will form the x and y axis. Now, you will be given an angle. In any case, you will somehow figure out one angle will always be given. Let's say this angle is given, theta. Now, just remember the rule. The axis which has theta, axis which has the angle receives the cos component. The cosine component comes here, okay? That means this will become cos theta and perpendicular to it, perpendicular to it will become sine theta. Means if I have this, I want to resolve its components. This side will become f cos theta perpendicular to it, where the angle is not adjacent. This will become f sine theta. Let me give you one example. Let's say we have a velocity of 3 meter per second. And I have given you this angle as 60 degree. Now you are to calculate the components of it. So one component C adjacent to the angle, this will become your cos component. This will be V cos theta. That is 3 into cos 60 degree, which is 3 by 2 meter per second. And this will be V sine 30. That will be 3 into sine 60 degree, which is 3 root 3 by 2 meter per second. Now class, if you take these two components, no, 3 root 3 by 2 and 3 by 2, and take the angle between them as 90 degree, use your parallelogram law, you will get this 3 back. So we are just going reverse. We used to have the vectors and we used to calculate their resultant under root a square plus b square using this equation. Now we have the resultant, we are splitting up into and getting the main equation. What if I change the angle? Let's say I give you this. Let's say this is some a vector, x-axis, y-axis. This is x-axis, this is y-axis. So that you relate that this is not in terms of axis, it's always in terms of angle. So when you are resolving this will become your a. Let's say there's some value ay, or the value a only. Let me take this as a only. The value a cos theta will come here and a sine theta will come here. So here in this, your a's component along y-axis, this is a cos theta, not sine theta. And ax means a's components along x-axis is a sine theta. So this is not fixed. You remember adjacent angle, whatever is the adjacent angle, it will become cos theta. And the perpendicular one will become sine theta. That's it. Even when the angle is changed. Don't remember it in terms of axis or anything. You remember the component of the main vector along the y-axis, this is this. Along the x-axis is this. If I change the angle to here, this will become cos theta. If I change the angle to here, it will become cos theta. That's how we write. So we'll practice this question. It will become a little clearer. Write it till here first. Okay, let's discuss this question. See, let's look at the vector F1. There are three forces given to you: 10 Newton, 5 Newton, 3 Newton. So look, F1 is in a plane. F1 is not along x-axis, y-axis or z-axis. F1 is in a plane making an angle of 30 degrees. So we need to take out its x and y components separately. So along x-axis, can anyone tell me what will be the value of the force? Which component should come? This is the angle. This is the axis. Just adjacent to the axis. What did I tell?
Cos theta, so 10 root 3 by 2 Newton.
Yes, cos component will come, correct. So this will become F1 cos 30 degree. F1 is 10. From here, you will get the value of cos 30 degree. That is root 3 by 2. So this is 5 root 3 Newton. So 10 Newton is the parent formula. Now you are extracting its components. So one of the components is 5 root 3. Now we have to look for the other remaining component. That is perpendicular one, we receive sine theta. So this one will be F1 sine 30 degree, which is 10 by 2, that is 5 Newton. Now when you take 5 root 3, you will get your 10 Newton back. Let's come to the F2, the second force, which is F2. Its magnitude is 5 Newton. It is making an angle of 37 degree. I have written here. See, few values you remember. Sine 37 is 3 by 5. Cos 37 is 4 by 5. Sine 53 degree is 4 by 5. And cos 53 degree is 3 by 5. Just note it afterwards at the corner somewhere, because this is often seen. 53 and 37 are often used. So let's resolve F2. F2's x component will come here. This is the axis. These are all straight lines. Draw them as proper straight lines. While drawing free-handedly, these are just getting lifted up. So this, when one will receive the cos component, right? Cosine will come here. So this becomes F2 cos 37. So F2 is 5. See, cos 37 from here, it is 4 by 5. So this makes it 4 Newton. 4 Newton over here. Now, the component which will overlap with F1. See, this will overlap with F1, right? You are taking the perpendicular to it. This becomes F2 sine 37 degree. That is 5 into 3 by 5, which is 3 Newton. Look, as 5 Newton, 3 Newton, 4 Newton. Under root 4 plus under root 4 square plus 3 square is what? Under root 25, which is 5 Newton. So we are going by the reverse process. Now, class, just tell me one thing. Does F3 need any resolution? Yes or no?
No, ma'am. It's already in the
No.
y-axis.
It's already along the y-axis. So we need not touch F2. But what's the point of all this? Like, why did we resolve it? What's the point? Why to take out the components? In order to solve it, how to simplify it? You cannot solve at any angle, at any values, at any coordinates. We have studied along x-axis and y-axis. So now one thing, class, how to resolve it? Let's say, let me talk about the x component. X-axis. I am getting the net force along x-axis. So how many forces are there along the x-axis? 2. F1 cos 30 and F2 cos 37. The rest of the forces are not along the x-axis. And both are in the opposite direction. It's like this is 4 Newton and this is 5 root 3 Newton. You have studied vectors in detail in parallelogram, right? This part only. You know, when two vectors are in opposite direction, angle is 180 degree. Remember the special case, R is equal to A minus B. We subtract. Recalling or not?
Yes.
We did three cases, A minus B, A plus B, and when it was perpendicular, under root A square plus B square. From that it is. If 5 root 3 will be greater than 4 Newton anyways. It will be even greater than 5. 5 into 1.73 will be something related to 6. So here the force along the x-axis will become 5 root 3 minus 4. Right? This is the value that will come. This is the along the x-axis. Come to the y-axis. Class, there are 3 forces along the y-axis. Right? 5 Newton, 3 Newton, and this 2 Newton. I'll write it again. Y-axis. See, one was 5 Newton due to the F1. One was 3 Newton due to F2. And one force was downwards, 2 Newton, that we didn't touch, we didn't disturb because it was already along the y-axis. That's why we didn't. See, in order to solve it, can I just club them because they both are in the same direction? So won't they get added? 5 and 3 will get added. This will become 8 Newton upwards, this side, right? So I have 8 Newton up and 2 Newton down. So net force along y-axis is 8 minus 2, that is 6 Newton. So I have this much of Newton along x-axis, this much of Newton along the y-axis. How to get the resultant value? One thing is sure that F and X are, X and Y are at 90 degrees to each other. Your resultant force will be under root of Fx square plus Fy square. Why? Because the angle between X and Y axis is 90 degrees. This is how we solve. Like this will be 5 root 3. What will be it? If we have it, 5 into 1.73, 8.65. This is around 8.65 minus 4, which is 4.65 Newton. So when I'll have the final answer, this will be under root of 4.65 whole square plus 6 whole square. Okay, this will be the result. Like this. So there were so many forces, so many vectors and at such different angles. Total answer of all the forces is this, whatever it will be. Is that clear? Why do we need this resolution of vectors?
Yes, ma'am. Clear.
Yes.
Any doubts? Okay, write it down. And if you have any queries, anything, please let me know. class, there is one topic, resolution of vectors in 3D. This has the least chance of coming in your school exams. Simra, I think you are prepared. You will appear for NEET. So for NEET, it will be helpful. Otherwise, in the NEET batch, we'll do these things. But this is included in the syllabus. Means the very least chance are there. Like this is the least important thing. So when you're revising the important thing, you can ignore it. But this is a part of your syllabus. That is, see, when vectors are resolved along the third axis also, which is your z-axis. So just imagine, I have drawn it in 2 dimensions, obviously. This is the limitation, I cannot draw it 3D. So just imagine, this is the angle between the z-axis and the x-axis. This is angle between the y-axis and z-axis, and z-axis and x-axis. Okay. Now, you know the angles are 90 degree. But if these angles, these are not axes, if these suppose are not taken as, suppose this is the angle like this. If I have the vectors like this. So this is not along x, y, and z axis, right? If I have the vectors like this, I hope you are understanding. The angle between all the three of them is something else. X and Y is something else, Y and this is something else, this and this is something else, like this. When we have all these at 90 degree to each other, it becomes a proper axis that you know is already at 90 degree to each other. So getting these components back along the 3 dimension is what is meant by resolution of components along 3D. So here we use cosines. We call these as directional cosines. I'll write it. Ax is a cos alpha. The a component will be a cos alpha. This a y component will be a cos beta, and z component will be a cos gamma. So you're taking the components on all the 3 axes this time. So magnitude of the vector will still be under root a square ax square plus ay square plus az square. And when you will add them, this is how you write it. Now cos alpha will be ax by a. From where? From here only. If ax is a cos alpha will be ax by a. Ax means component along x-axis by a. What is a? The magnitude of a. That's how you get all these angles, right? Cos alpha's value, cos beta's values, and cos gamma's value. Ax by a, ay by a, az by a, like this. Now, when I square all of these cos alpha, cos beta, and cos gamma and add it, I'll get the vector answer as 1. See here. This is under root ax square plus ay square plus az square, right? So these have the magnitude as a square. So when we put it, this a square plus ay square plus az square, this is a square divided by a square. That is 1. So in some of the school papers, not recently, this derivation came that proved that the sum of directional cosines. This is basically called as the directional cosines. So one question came that prove that the sum of all the directional cosines is 1. So this is how you can show. Because you know your cos alpha is ax by a, cos beta is ay by a, cos gamma is az by a. So when you square it, it becomes ax square by a square plus ay square by a square plus az square by a square. Actually, see from here, you know, a is under root ax square plus ay square plus az square. So when I square it, if I have, let's say, under root a is equal to a vector is what? A is equal to under root of ax square plus ay square plus az square. This is the magnitude of it. I should remove the vector sign. This is the magnitude of it. If I square it on both the sides, this will be a square, ax square plus ay square plus az square. This a square I have written here, which is equal to 1. Is it clear? No. Okay.
Ma'am, when we are squaring it,
Yeah.
and when you wrote it in blue when we're squaring, won't
Yes.
the a also get squared because we are whole ax the whole square, right? So won't it
Yeah.
be
So
a
we have squared a
square?
square.
No, ma'am, on the
Was
numerator.
numerator.
Yeah.
Numerator is after squaring these, we are getting ax square. Okay, I'll repeat this. This is a little tough, I understand. I'll repeat this. Wait. Basically, you have the components in 3 dimensions. Okay, 3 dimensions means earlier I was talking about two random angles like this. Random angles were there, right? And their resultant was lying somewhere here. Let's say this is the resultant of it. Okay, this is the resultant. That's what we have studied in the parallelogram. Now we just have this. We wanted these two. So these are two. So this was the rectangular components in 2D, which we have studied. If a third axis is also taken, like they are in the same plane, if I shift its plane like this, the angle is different between all of these. This is what is there, rectangular components in 3D. Three vectors are there, or one main vector is there, whose three components are present. Here there must be a main vector whose three components are there, one along some axis, one along some axis, one along some axis. This is the meaning of it. First tell me, this meaning you have understood?
Yes, ma'am. Yes, ma'am.
Okay. This is the formula of it. Ax is a cos alpha. Now, how is this derived? This is completely out of your syllabus. You don't need to do that. Just remember, a vector means a is the main vector. Okay. Ax means you are taking its component along x-axis, and angle is alpha. So we write component along x-axis is what is the angle? Alpha here, right? So we take ax as a cos alpha. Similarly, when we are talking about the y-axis, this will be a cos beta. This will be a cos gamma. Till here it's clear? Okay. Now
Yes.
from here, if I write the values of cos alpha, cos beta, cos gamma, what will it be? This, right? Now, if I square it, it will become ax square by a square. This will become ay square by a square. This will become az square by a square, right? We are squaring all the individual angles, all the individual cos components we are squaring, right? Like this, cos alpha, cos beta, cos gamma. All these will be squared up. When you add them, you will be stuck at this step, right? Because ax square plus ay square plus az square, this is unclear. When you square it and add it, you will be left at this step, ax square plus ay square plus az square by a square. For this, I wrote this. When you have the main vector a, how do you write its magnitude? Under root ax square plus ay square plus az square. You square on both sides. You will get a square, right? A square is equal to ax square plus ay square plus az square. This whole value, I have put it in term instead of this. So a square by a square is 1. So Neha, which you were saying that squaring, we are not squaring ax square, that it will become ax to the power 4. Right, we just have ax and we are squaring this ax. Is that clear, the doubt which you were asking, Neha?
Yes, ma'am.
And similar, now it's clear. How do we prove that it's equal to 1?
Yes, ma'am, clear.
Do one thing, write it till here. I'll make you practice a question also on this. If still you are not able to understand any one of you, I'll repeat it. Okay? Please write it. Look at this question. See, you have the vector A as 2i cap minus 3j cap plus 4k cap. Now we have to find out first, the first part is magnitude of A. So magnitude of A will be given by under root of 2 square plus minus 3 whole square plus 4 square. So this will be 4 plus this is 9 plus this is 16. This is root 29. Second says direction cosines. So in direction cosines means cos alpha will be ax by the magnitude of A. So see, ax is 2, 2 by root 29. Like this. This is how you have to solve. Cos beta, this will be ay by the vector magnitude of it. So 3 by root 29. Cos gamma, this is az by a. These are all the magnitudes, which will be 4 by root 29. See, when you add all these vectorically, 2 by root 29 plus 3 by root 29 plus 4 by root 29, when you square them and add, it will be 2 by 29, 4 by 29 plus 9 by 29 plus 16 by 29. 2 plus 3, 4 plus 9 plus 16 is again 29. So 29 by 29 is 1. Right? This is what we did here. Okay. Just write down this, then we'll start with the dot product.
Cos, we don't have to take the negative sign for cos beta
No?
because it's minus 3.
No. We are taking the component. You even if you take minus 3, it won't affect it, but here you can take just the magnitudes of it. Okay, because you're just taking the components. Here, if it is negative, you can take negative because ultimately it will be squared up. You take negative, your answer will come out to be the same. See, coming to the introduction of what is dot product and what is meant by cross product. See, when you have multiplication of vectors, vectors can be multiplied by just a number. When you multiply vector with just a number, so the vector will become n times. Here in this case, becomes vector becomes n times. Like if I have a number with me, let's say f is equal to 2 Newton, and I'm multiplying it, I'm doubling it. So now the new vector will be 2 into 2, which is 4 Newton. So straight away with the number, you just make it n times if n is the number, where n is your number. Then you have when vectors are being multiplied with a scalar quantity. Okay, vector getting multiplied to a scalar. So this is also your simple multiplication when vector is multiplied to a scalar quantity. Let's say your distance displacement is being multiplied. So whatever is the product, it will be put as it is. Like let's say there is one vector whose answer is 2 I cap, and there is one scalar vector whose value is, let's say, 4 meter. Okay, this is the value for, or let me make it unit. Let's not write it for distance. Let's write it generally. Let's say this is some 4 units scalar quantity. This is 2 I cap. On multiplying, it will become 2 into 4, that is 8 I cap units. All the things will get multiplied. So these two topics need not require any proper classes. This is a simple multiplication, and you'll all be able to multiply. Problem comes when you multiply vector with a vector quantity. When a vector is multiplied to a vector quantity, how does it affect it? See, when the this depends on what is the resultant. Okay, this completely depends on what is the resultant. If we say the resultant is, let's say, a scalar quantity, this is the resultant, means vector into vector is giving you the scalar quantity. You use dot product. And when the resultant is also a vector, you use cross product. Because this is something new which we need to study out of this whole chart. Multiplication you will all be able to do. Putting the units and all these vector signs you will be able to do. But dot product is something different, cross product is something different that you would not be able to do. Right? So that we have to study dot product and cross product. I'll start first with the dot product. Now see, units remain the same in both the cases. Like this was an example which I was telling you. Let's say f is a vector 2 I cap. So when I have number is, let's say, 3. So when I want the resultant, let's say resultant will be f into n, means n times f. So 2 I cap into 3 will become 6 I cap Newton. This is the resultant. Or when a vector is being multiplied to a scalar, f is equal to ma. Force is mass into acceleration. Mass is 2, acceleration is 2 I cap. Now, why? I hope you remember this. F is equal to ma, ninth class, Introduction to Motion. You must have studied, right? Now you will study it in laws of motion. The next chapter we'll do the derivation and everything again. So this is also 4 I cap, and we'll put the units as it is. Kg meter per second square. Though 1 kg meter per second square is actually Newton. But right now we are not focusing on the force. We are focusing on how we write it. So units remain the same. These are very easy, right? You just need to multiply whatever are the units. Units ko as it is likh do bas. As it is. From here, multiply the units also. Negative sign hai to negative sign ko bhi multiply kar lo. I cap hai to I cap ko multiply karo. Whatever is given. Dot product and cross products are something else that we need to study properly. And it is very helpful, not for your class 11. In fact, I have told you multiple times that vectors, integration and differentiation. Do these things properly for your 12th also. 12th में boards देना है, right? For board exams, you need to have a good base for that. Please write it down till here. If time is left, I'll start with the dot product first. Okay, class. So we'll not be able to complete the dot product today. I'll start it tomorrow only then. Dot product we'll try to complete it tomorrow, and I'll start with cross product only tomorrow. Okay, so if you have written Simra and Neha, let's meet tomorrow then. Okay, thank you. Then bye.
Thank you, ma'am.
Thank you, ma'am.